Hello everybody. Today we are solving another differential equation, and today we're going to be solving one which is y double prime plus y equals secant x. So let's just get straight into this, and we're going to be doing this today by the method of variation of parameters. Okay, so let's do it. So first of all we need to find our complementary solution, okay, y is c. So for this we're going to set y double prime plus y equal to 0, okay, and to solve this we're going to guess that y equals e to the rt. From this we get that e to the rt, the second derivative of this we're going to get an r squared plus e to the rt equals 0. Now if we divide out by e to the rt, we are going to get this. Okay, r squared plus 1 equals 0, r squared equals minus 1, r equals plus or minus the square root of negative 1, which equals plus or minus I. So y equals e to the plus or minus I t. Sorry, I don't know why I'm using t when we're using x's, you know? I mean, I just don't know. So this is going to be c1 cosine x plus c2 sine of x because of Euler's identity. Okay, so I'm just going to rub all this out, and I'll put our answer for the complementary solution just up here. So let's say y of c, that's the complementary solution, it's going to be c1 cosine x plus c2 sine of x. Okay, very nice. From this we get that y1 equals, okay, so we've got y1 here, which is cosine x, y2 is sine of x, of course, and we're actually going to do something where we take the derivatives of these. Okay, so get y prime of 1 equals minus sine x, and y2 prime equals cosine x. And with this we're going to create something called the Wronskian, I think it's pronounced like that, and this is going to be, should make that a bit bigger actually, let's go all the way up here, that should be good. So from this we're going to do y1, y2, y1 prime and y2 prime. Okay, very nice. So this is just going to, this is just going to be cosine x, sine of x, minus sine of x, and cosine x. And these sort of bars on the outside, these sort of absolute value symbols, this means we just take the determinant of this. So we're going to do cosine x times cosine x, which is cosine squared, of course. So we're taking the determinant of this matrix, and then so we do this, multiply these, and we minus the product of these, which is going to be negative sine squared, but we're minusing minus sine squared. So we get a plus sine squared, which equals 1, of course. So that's very nice. And now we're going to get our w1, okay, which is going to be, so we do 0 f of x, so 0 f of x is secant x, so it's going to be secant x here. Okay, secant x, and then we just leave the second two as they were. So it's going to be sine and cosine x. We do the same of this, you multiply these two, and that'll get us 0 of course, and we do minus sine times secant. Well, secant is just 1 over cosine, so it's going to be minus sine x over cosine x, which is minus tangent x, which equals W1. Very nice. So now we're going to find W2. We pretty much do the same thing, but this time we leave the first column, which is cosine x minus sine x. And then we do the same thing, we put in 0 and f of x, which is secant x. And these two are going to go away, so you can ignore them. Cosine x and secant x is cosine x divided by cosine x, because secant x is 1 over cosine x, which gives us 1. Very nice. Now we have something called u1 and u2, and finally, by the way, at the end we're going to get y of h, which is sort of I should really say y of p, our particular solution, is just going to be y1 u1 plus y2 u2. That'll be our particular solution. So what's okay, what are u1 and u2? So u1 is going to be the integral of w1 over w dx, which equals the integral. W1 is minus tangent x, but it's being divided by 1 because w is 1. So yeah, w is 1. So we're just going to write the negative integral of tangent x dx, which is of course negative sine x over cosine x dx. Now we can do a u sub here. If we say u equals cosine x, du equals minus sine x, bring the minus out here. So now we're going to replace sine x dx with minus du. The minuses will cancel and it will give us 1 over u du, which is the natural log of u, which is cosine x. Very nice. So that's our u1. For our u2, this one is like really tricky to evaluate. This integral is quite horrible, to be honest. It's just 1 over 1, so it's x. That was a joke. This isn't too hard. Not hard at all, actually. So we have u1 and u2 now. So now we can say that our particular solution is y1, which I believe was cosine x. So it's going to be cosine x times the natural log of cosine x plus y2, which is sine x, multiplied by x. Okay, so that's y of p. And now, for our general solution, it's going to be y equals y sub c plus y sub p. So it's the complementary solution and the particular solution summed. Sorry. So y is going to be c1 cosine x plus c2 sine of x plus, and here we have cosine x times the natural log of cosine x plus x multiplied by sine of x. And so this is our solution today. So yeah, I hope you enjoyed the video today. This was a bit of a harder differential equation, but not too hard. So yeah, thank you for watching, and goodbye.